Okay, so here's the information that we got from the Desmos, and now we're going to plot it right here on the paper. So we're going to do the quadratic first. Now these boxes are tiny, so you got to be real careful. Negative 1, 0 is here, and 5, 0 is here. Our y-intercept is 0, negative 5. And the vertex is at 2, negative 9. So be real careful that you are accurate. Here are the pieces of my quadratic. So I'm going to go ahead and connect. Should look like that. All right. Now what I need to do is I need to do linear. I'm going to try a different color this time. I'm going to try green just so that you can see where the linear hits the quadratic. Maybe this will make a little difference. I'm not sure. So remember that at negative 1, 0, that is a point. That's the x-intercept for the linear. Y-intercept's at 0, 2. And then we have a point at 7, 16. Ooh, that's way up here. And basically, because I know this is a slope of 2 and it goes up by 2 over 1, I can just kind of fill in a little bit. Just get the pattern there so it's easier. So I'm going to put this line in, and then we're going to fix this quadratic. Now, why does my quadratic need fixing? Well, I didn't extend it far enough because it intersects way up here. So I am going to do a little bit of magic right there. I know it has to intersect there. That was silly of me because I saw the intersection, right? On the Desmos, it goes all the way up there. Okay, so you want to make sure that you have, here we go. There we go. That you have the quadratic extending all the way up with the line. Okay, so that's like a common mistake, and it happens just because we don't know where the line is going to hit. So that's why we write the points of intersection down. Keep in mind, again, that the key and crucial piece here is literally the x coordinates of the points of intersection. So I'm focusing on what is happening between negative 1 and positive 7. So what is happening between negative 1 here and 7 here across the x-axis. We have to go up and take a look and see what they're looking for. In this case, this is the quadratic, and they want the quadratic. This symbol is greater than. So greater than means above the line. So quadratic is greater than the linear. So that means we want the quadratic above the line. Where's the quadratic? Above the line. Okay, so here's my line. So my quadratic is above the line here, and it's above the line here. Notice it's in two pieces. This is where it's above the line. So I've got two pieces of solutions here. Two pieces this time. This is one piece because it makes a loop. One loop makes a one piece, and it's in between. Here, this is two separate pieces that are poking up above the line. So two pieces is easier to actually do. Open or closed. When you look over here, it's got an equal sign. So this is a closed circle. So I'm going to go to negative 1. This is the x coordinates that I'm focusing on. X values for your points of intersection or what you use. So closed circle on negative 1. Closed circle on 7. And they're two separate pieces. So when there's two separate pieces, you go in opposite directions. So you've got this guy here, and you've got this one here going in this direction all the way that way. So that's what it looks like. That's what it is on the number line. So when you have two pieces that are poking out, you're going to have opposite ends going. And we're using the x values of our points of intersection to determine that. Closed circle because it's an equal to. When I go to write this symbolically, because there are two pieces, the number line is going to have two pieces, and then our solution is going to have two pieces. This left solution is x is less than or equal to -1. This is less because it's left, equal to, close circle. Or on this side, you've got x is greater than or equal to 7. And that's because greater than is to the right. And the 7 is closed circle, so you've got the equal to. So this is what it is symbolically. This is what it is on the number line. And this is what it looks like graphically.